created my own degree back in 1990. I wanted to do a sustainability, it didn't exist, so I picked and choose from all of the very bad English to start with. Pick the classes that I wanted to do that I think what I needed to know about, so geology, climate science, ecology, botany. Can everyone hear me? Can you hear me all right? Yeah. And then I did my final year at the University of Amsterdam, specialising in environmental science and environmental economics, environmental governance and life cycle assessment. Then I followed that up with a Masters in Engineering, where I looked at cleaner production, so working in factories and working on processes to try and minimise the impact of our production processes. Then I went and worked internationally as a consultant for a few years, and I was my 333rd grade day in the Netherlands, so that's it, I'm coming back to Melbourne. And I was offered a position at RMIT University as long as I did a PhD. I was like, oh, yeah, I do a PhD, it's a job. And when I came out of university, it was the 90s recession, so there weren't any jobs, so being offered a job, I was going to do whatever they wanted me to do, within reason. And so that's my background. I finished my PhD in 2005 and have been at Melbourne Uni since 2006, where I teach environmental building systems to the undergraduates, and I do research in what's the next stage of sustainability. We've been talking about this efficiency stuff for a long time. What's the next stage? That's where my research is at now. I'm also a mother and wife to Carrie and wife to sons. And they're also a very important part of my life. That's my today I'll talk about shading, water and energy nexus, research that we did at Melbourne Uni. I'll talk about green roofs and I'll talk about net positive homes. I have spoken at the ATA before on white roofs, so I'll just touch on that compared to green roofs, but I won't go into it because it's not part of the natural systems that I'm talking about today. I'll then talk about microclimates, nature and us, and the future. So starting with energy, and I'm not spending one slide on this because I assume being ATA members, you're probably more expert on this than I am. But where can nature actually help us with our energy consumption in our homes? Well, nature can help us on the heating side. Nature can help us on the cooling side. Now, for Melbourne, our cooling isn't that high, but it is an increasing issue that we'll have to deal with the climate change expectations. And it can help us with our costs. So that's really where nature can help us. Nature can also help us on other aspects, which I'll touch on at the end, that aren't energy related. We're talking about 4 Melbourne University projects now in quick succession. So our green roofs work, our green walls work, our trees, and our energy positive, the start of our energy positive work. And I say we, because it's not just me. I'm a small cog in a much bigger machine. All of these are my colleagues that I work on all of this work with. We've had some funding from various organisations, and we've got industry partners that have worked with us. Some of those on the white roofs side of things, some of that on the green roof side of things. This is our site, and I use this slide for people who don't know where Melbourne or Australia are, just to show them where it is, but it's right there in the bend. These are all my buildings, and I'll go through them in a second and explain them all. So we have building A that has trees around it, evergreens. We have building B that's out control. We have building C that has our deciduous trees. We have building D that's one type of white roof paint. We have building E that's a green roof. We have building F that's another type of white roof paint. We have building G called Dominique's Folly. It's a quarter scale. It's at this height, so I can clean the white roof and see what impact evergreen has on that white roof on its performance. And then we have buildings H and J, which are half-scale buildings built to 6-star standards, so that we can see whether white roofs, in this case, make any difference when it's already 6-star design. I'm not going to talk about B, D, F, G, H, J. I'm going to talk about the greenery stuff. And all of that information is available if you're interested. So these are the dimensions of the buildings. They're all 12 square metre buildings that they used to use at the Crestwood campus to put students in. So, we retrofitted them. bringing them up to standard and putting the white paint on them and putting the green roofs on. These are the, I'm going to talk about building E, the green roof project, but we also compared it to the performance of the white roofs so that we could honestly talk about which kind of retrofit option is the most beneficial. And the other green roof retrofit is this green roof on the Berkeley admin roof, and so I'll talk a little bit about that because it's a much bigger scale and they use air conditioning in this building, so we will talk about the energy savings that the nature has provided in this building. It's also a lovely space. If you're ever at Burnley, have people been to the green roof? It's lovely. Yeah. Considering it used to be black bitumen and ugly and leaked, it now is beautiful and not hot. And we love to be out there and it still leaks. Alright, so what are the results that we found? In our little buildings that weren't air conditioned, the difference that the green roof made is 4 degrees. And 2 degrees or more in winter. So it made a benefit in summer and it made a benefit in winter. And we're hoping to do a next stage research project because the R value of the green roof changes as water is added to it because all the air pockets that insulate it when there's no water then get connected when there's water and then the R value goes down. So we're doing a research project trying to have a dynamic R value. That's not completed, but this is the real data. In those little homes, this is what happened across 2 years. On the large building, the rooms directly under the green roof used 48% less energy for their cooling. So again, the direct, even though the R value changed across the year, this is a summer, use air conditioning result, but across the data with the R value changing with the moisture, we still have this benefit of 48%. So here we have nature adding to the beauty of the place and the amenity of the place, but also giving us an energy benefit. What we also did is have our thermal camera and take thermal measurements, and in a later image I'll have the details of all the monitoring, but we were taking the radiation images from the roof going up, and both horizontally and vertically, so anything bouncing, because the roof was at about a 6-degree pitch. So we were tracking what energy was bouncing off that was sunlight. And with the green roof, we got very little bounce. Whereas the white roof, the reason the white roof works so well is that it bounces all of that radiant energy from the sun off the building. So the green roof doesn't do that. The plants absorb that energy to create their food. The water evapotranspirates, that also uses energy. So all of these things is using that solar energy, which means that there isn't any radiant, and the plants don't reflect light, the ones that we use. Malcolm, come in.
Over here.
There was no, so again with the thermal camera going through, there was no heat transfer through the roof, whereas with the control building, holding the thermal camera up, you could see that still there was some thermal enrichment where insulation was between the two of the studs, rafters, and there was some energy coming through. The green roof that didn't happen, again because the plants were absorbing all of that heat. And the roof temperature actually stayed at the ambient temperature. And I've already explained why. Because the plants were absorbing that heat. It wasn't being stored by the materials, and it wasn't being re-radiated. Evapotranspiration, insulation, plants were absorbed. So, through the research, we could show that green roofs do not re-radiate heat back into the environment, so they help with the urban environment. The areas around the green roofs are cooler than the areas where there isn't a green roof. So it helps with the urban environment. It reduces energy costs. Yep.
UHI is?
Urban heat island. Yep. So the fact that the city is 4 to 6 degrees warmer in the countryside because we have more surface area with darker materials that hold onto that heat. And we also have air conditioning systems that take the heat from inside the building and give it outside the building. So it's an issue because on a 40-degree day, that means the city could be 46. And that's really dangerous for our environment. It creates a better microclimate, so you have that We also tried different species that have more leaves. That's those buildings with big being the control. For these buildings, we actually had an air conditioner in there so that we could measure the amount of energy. The air conditioner was too big for the small space, so we also had periods where we just switched the air conditioner off so that we could see what the actual impact it was without the air conditioner as we did for the other buildings. We looked at thermal transfer through each of the surfaces and we weighed the trees for how much water they were absorbing because we were really interested in, because remember due to drought we weren't allowed to water our trees and our trees died, which meant our houses didn't get shaded and so our energy used to fill up and that burning island got burst and so our energy went up. So we're very interested in that question of how much water does it take to maintain these trees and what impact does it have on the energy consumption of the building. So that was what this research was about. So again, very briefly, and I can provide the full reports and the papers to anyone that's interested. I've got a bunch of cards, so please take one. So visually, the thermal cameras, you can see the emissivity there at 70. This was my first use of the thermal camera. I should have set the emissivity up at about 90. You can see these are weatherboards and they're a little bit reflected. But they're all the same, so you can still see the relative change in temperature. So here we have, at the same time, photo on the wall, 41 degrees, photo on the shade, 26 degrees.
Is that a photo of the interior?
No, it's the exterior. That's the photo of the interior.
Sorry.
That's all right, that's a great question. So again, the insulation was doing something, but it wasn't doing everything. The shading was actually making a significant difference.
Are those temperatures the air temperature inside and out?
Surface.
Right.
Surface. So we also recorded air temperature and all those sort of details, which is up to 10 degrees difference when we didn't cool those buildings. So remember, we had the air conditioning on there to see what the energy use was, but because the air conditioning was too big, we didn't really get anything meaningful out of them. So this is for the 2-week control weeks that we had across 2 years where we left the building without air conditioning. There was a 10-degree difference between the shaded building and the non-shaded building. Remember, these roofs weren't painted white, so they were just the 20-year-old corrugated iron.
So the 41-degree one looks like it's got trees in front of it.
Yep, so the shade of the trees, this is taken at the same time, it stops there.
Okay, so different parts of the same wall.
Yeah, it's just different parts of the same wall, it's just showing the impact of that shade. Yep, and this is the same wall at the same point. That point is that when we measured it. And this point is lower down on the same wall, showing that gradient, that impact of that gradient. 36% decrease in the thermal load. Remember, it's a 12 square metre building. We didn't have windows open, we didn't have airflow through, but this is showing that the trees were making a big difference. And at very little water cost. So we could show that we used less than 5% of the water that to keep those trees alive, the energy benefit we would have used for the increased energy, the 36% increased energy to keep that building to comfort levels. So, and that went back, so next time we have a drought, they won't make us not water our trees.
Certainly you actually use less water keeping the trees alive than you ran in the back cooler.
No, you use less water than the power stations use to create the energy that we needed to keep the house cool to the same temperature as we would have kept with the shading to deal with that extra heat load.
You said it's 5%. You use 5%.
I'll get you the exact, I should have put the exact, but while Rob's talking, I'll give you the exact number. I can find you the papers. So again, the trees, less radiation off the walls, the trees are absorbing that energy and then we have the shade, less urban heat island contribution, less energy costs, less water costs, creating a better climate and giving us better amenity. I'll keep going because I don't want to go into Rob's time. examples of home green walls, so the images of site. And this is a larger scale one in Sydney at Central Park Apartments. Very interesting project. It does take 7 gardeners to keep that green wall across this building alive and all the grounds as well. But that's where humans want nature to be part of their infrastructure. We do need to start working with nature and replacing it with it does. Understanding its water needs, understanding what works where. So that's a very interesting project, but we're talking residential scale, so look at the other photos. And this research is ongoing, so I can't present any results. So at the Melbourne Uni at Melbourne campus, we have some test green walls, and we've got sensors that measure all of these aspects. So not only radiation from and all of the information from the external part of the green wall, but also looking at what's happening at that interface between the green wall and the building. Because you can imagine if you've got a gale wind going through there, then that green wall is not going to have as much of an impact than if it's a very still courtyard. And so having those elements are all being looked at. What they have found, and this is the paper that you can look up through this, and here's just a thermal image showing the difference. Again, that the greenery isn't giving off as much heat. They give recommendations around if you have a green wall, you need to look at your species, wind load, water availability, the amount of sun. I've got one research student who's called that biological feasibility. And so he's working on this concept of developing a biological feasibility guide for green walls. So you can say I've got a western wall, it's 2 stories, I've got some soil underneath, and it'll give you these are the plants you could plant for Melbourne. So that's exciting. And they have shown thermal benefits, but this is only very preliminary, so I don't have any figures to give you, but particularly the east and the west where the sun is shining most directly onto our vertical surfaces. So keep your eyes peeled. So to conclude, greeneries will reduce cooling energy, green walls will reduce cooling energy, trees will reduce cooling energy, deciduous trees are best because in the benefit of the winter. But our insulation is quite, our insulation regulation is quite good, so the benefit you're getting is on the microclimate rather than in winter your building not being kept too cold by the shade. That makes sense. And they all provide other benefits, but remember they're natural systems, they're non-mechanical systems. I have worked on many projects where the one thing that has stopped the building being finally signed off is that the natural elements, the facade or the roof or whatever, hasn't quite taken yet. They haven't quite got the water recycling ready. So people tend to specify these green things as if they are mechanical systems, but they are natural systems, and so we need to think about maintenance, water costs, and so forth. And the greatest of these is trees. To get the impact of 7% increase in trees in the Melbourne suburban area in summer, and this is where the white roof comes in, we would have to reduce the albedo or the reflectivity, to put it crudely, of our roofs by 48%. So 48% of our roofs need to be decreased from a grey to white so that they reflect more energy. And remember, reflecting that energy is still putting the energy into the atmosphere, so trees is the way to go. This is a really useful guide. It will tell you what plants you can plant at what depth, on what type of roof surfaces, how to plant green walls and so on. So now to the last little bit.
I had a question about that, and that I was wondering what sort of plants would you use, because a lot of plants would need pruning and maintenance.
Well, the benefits that we got at our small scale studies at Burnley were with supplements. So we got a good benefit even though we were using supplements and they require very little maintenance, though we did get some weeds. And the Burnley guys have also developed a very special mixture that the plants can grow in that is lightweight but holds lots of moisture and so forth. The other green roof, the bigger one, there's a herb garden, there's a vegetable garden, there's all sorts of different plants. Half of it, the right half, is not irrigated, the left half is irrigated, so what's going on there. So what plants, it would depend which way the roof is facing, what else is going on. But I would, and if you have access to it or not. But we got a good benefit with the succulents. But that growing green guide also depends, do you want to use it as a garden that you attract more, do you want to grow vegetables? The next bit of the talk was really to talk about the future and to weave the environment through that. And that's what I'm seeing is that people are aiming to go to neutral, and we saw that with the Beyond Zero Emissions report that showed how every house could go towards zero emissions. Projects such as, that's weird. Actually, we won't go round and round in circles. He's going to recap. Very quickly. Trees good. Very strange. So, and do you know the Aurora House project? Yeah. Bunch of students, University of Wollongong, took an old fibro 50s home, upgraded it to zero carbon and really efficient water and permaculture garden and all of that groovy stuff, and then dismantled it, took it to China as part of the solar decathlon and won. So from the whole world, they were very impressed with what these students had done. Not just that they were able to build a zero energy, zero carbon home, but they were able to take an old home and get it to that standard. So it's not just about new, it's also what we need to do it. And so that got me thinking, because I'm sick of this efficiency conversation, because being 50% more efficient still means that we're being 50% bad. Okay? We're being 50% harmful. Being zero is kind of not very exciting to me. Sustaining things as they are, no, better and growing. Sustainable marriage, I think I've used this with you guys before, but a sustainable marriage would be going, is that you okay? You know what a sustainable marriage is, an exciting, vibrant, that you're just happy every time you see each other, sort of marriage. Not all the time, but so I'm really interested in that next step. How can we start becoming positive citizens in the world and start fixing some of the issues? And so I've got some students of mine, and this is very preliminary, to work with the City of Moreland and look at their existing stock and say, can we make your houses energy positive or carbon positive? Carbon positive. And so what they did is they looked at the use of an average home from the data, the lighting, the cooking, and then said, okay, if we make all of that large section really efficient, and then we'll need this much PV to deal with that. And then if with the roof sizes, so we did Google roof size mapping, what was the total PV that we could put on, and we could put a few extra panels once we were really efficient. And then we said, okay, what else could we do if we wanted to become carbon positive? And so we looked at micro wind, we looked at biochar, and the results are very preliminary, and we'd like to get something to do with more of this, but showed that we could actually, through the additional solar panels that we could put on our roof surfaces and a little bit of addition of microwind and a bit of addition of biochar, we could actually start absorbing more carbon and start sort of reducing the parts per million of carbon in the air around. So that was quite exciting to see that actually the numbers, if we were able to retrofit things to be very efficient, that was possible. And lo and behold, this year, and if you go to City Square, you can see this building. We have our first carbon positive prefab home. So carbon positive is possible if you're using a lot of things that have embedded carbon in timber products. And these slides I think will be made available so you can look at the detail of the design. Of course, very needful of placement. If you have it passively designed and you turn your back on the sun, it's not going to work, so it's always designed to place. But in optimum placement, with all of the systems that are put in place, this building not only holds a lot of carbon through its timber, but also returns more to the grid read through all this materials online, so you can have a look at all the elements of this. So it is possible to be positive. The other thing that I'm really interested in is not just about energy, but how we relate with our environment and the impact that the environment has on us. And that's the health aspect of it. So this talk was about how nature can help us be more energy efficient, but also healthy. Because healthy homes connected to nature have been shown to be better mentally and physically for our development. Pragmatically, they can help us with natural ventilation, sunlight, shade, microclimates and other benefits that I've already spoken about. They also give us this connection to the outside, to what's happening with climate, what's happening with our plants, what's happening with our neighbours, and windows also provide use of natural light. And this is called biophilia. And I'll go through this very, very quickly. It's that connection to nature that Edward Wilson, a social biologist, found is actually critical to our well-being. They've done the research in the brain and they've followed the chemicals and happy chemicals and sad chemicals and looked at massive population studies as well as health studies, and have shown that connection to nature is a critical factor for both social, psychological and physical well-being. These are two of the best books from him. From Stephen Pillett, who takes this work then further into the built environment. How do we incorporate these natural features to the point that we can perform at our best? And this connection to nature can be a beautiful view out of a window to a fern, as I have here, but it can also be natural shapes, it can also be a pot plant, an abstract image. All of those connections to nature are good for our well-being. The medical research has shown enhances health and well-being, fewer social problems, improved productivity. You've probably heard a lot of this stuff already, improved concentration, maturation development. When most students get stressed at the end of the semester, I say go sit outside in the park. Forget your computer, forget your iPhone, you go to your home, just go for a walk. And they report back that it works. Though not many people take that suggestion up. And why? Now, this is a video, and I'm not going to show it to you because we don't have time. It only takes 5 minutes, but it will take you very briefly through how the brain works. And I'll just explain it in 1 minute. The bottom bit of our brain is our reptilian brain. It's the brain that does the fight-flight. I'm scared, I'm going to run or I'm going to fight. It's the bit of the brain that was evolved when we were having to deal with all of the natural elements. So colours would signify what foods were good, what foods weren't. Being able to see what was happening with the weather meant that we knew how to survive the mess, because those that survived knew how to deal with those things. So this bit of the brain evolved to react to what's going around in nature around us. This bit of the brain also, if it's stressed, stops the signals getting from everywhere, because all of our signals go through this bit of the brain first, because it needs to know whether we need to run first or not. That's how we evolved, running fast and getting away from this one. Before it goes and gets processed at these higher levels of creativity, being able to interpret things, being able to communicate, socialise, all of this level. This bit is stressed because it's disconnected from nature. All of these bits don't work properly. So that's very briefly, and you can watch the video and get a much more scientific version of that. But that's what they've shown through the biophilia research. We need connection to nature to relax this bit so that we can work most effectively at this level. And so by providing our green roofs, our green walls, and our trees, we're not just providing energy benefits, we're providing these other benefits that mean that we can be a more productive society. Productive in the wealth sense rather than the richness sense, because wealth is about enjoyment, connectivity, money. So the dimensions of biophilia design, I won't read through them, but I'll just show you a few examples. There's lots of them. And that really just helps designers in understanding how to connect at various levels. These slides again will be available to you. So but for example, water, if we have a running stream or if we have a little pond in our gardens, that bit remembers that we have water, we have enough to drink. That is part of our survival needs. We survive because we've been near water, and so this bit's more relaxed. So if have the sound water, and if you have that humidity that balance caused by water around it, smell of water, who feels fantastic when they can smell the rain coming? That is part of that system. This is the Museum of the Native American Indian, which has this river that's natural to the place running through this building that's designed in a very, sorry, I'm getting distracted. Sunlight, we need to be connected to it because of circadian rhythms, and again, the circadian rhythms are linked to our base brain because whether the sun was shining or it was dark, when you had to act to survive. I just want to stop with this one. Plants in the house. There are some plants that work by wood out of Sydney has shown are the best to have in the house because they absorb the most chemicals, they absorb the most CO2, they absorb the most particulates, but you need to clean them every so often because once they're full of little particulates, they won't absorb, they don't absorb them, they just attach to the surfaces, so do clean your plants. But these are the key plants to have in your home for health. And then there's this fantastic TED talk about this Indian guy who in Mumbai, where the air was so bad outside that he just sealed up his whole building and worked out how many plants he needed to have in the building so that everyone could have really good air quality. Really recommend this. It's hilarious. And this is the research that goes behind which plants to have in the house, which leads to the 6 recommendations up there. Linking to geology and natural patterns, we respond to sort of Fibonacci kind of patterns, the patterns of even proportions, the shell sort of patterns. There's a natural pattern that comes from the environment that we often repeat in our buildings. We probably don't even know. We walk into a building and we feel just right. And again, it's something that I haven't quite worked out why that is part of this base brain is relaxed in those situations, but I think it's because of that reference to the natural. This is the map. They've used water very well through their buildings as a way of both dealing with some acoustic issues, dealing with some thermal issues, but mainly really bringing those biophilic aspects, bringing natural shapes into it, shells, natural shapes. Linking to the local geology, this is a stone wall in Sydney, has all the thermal benefits of having a huge bit of thermal mass there, but also the rainwater runs down this when it's raining, the sun shines on it and heats it up and provides some thermal benefits. Again, nature meeting us halfway as far as our energy reduction goes. And learning from nature by memory. This is our CH2 building, which was designed based on a termite. Didn't quite work well because we don't have termites in Victoria, or not in the Melbourne area at least. So, you know, there were other biomimicry things that we could have applied there, but the initial thought was good. And this is just because I love flowers and being able to pick the flowers and put them in my salads and freak my visitors out. So these are the flowers you can grow in your garden, get the biophilic elements, get the energy savings, and put them in your salads. So that's really that sort of future stuff. So I've talked about carbon neutral, carbon positive, and biophilic. There's 3 more things that's coming in the next few years that you'll hear more about, and that's restorative design, which is trying to restore things. So bringing back nature, bringing back, removing feral animals, bringing back more native trees or appropriate trees. The next stage to that is regenerative. I've published a book which kind of outlines some of this stuff. There is a 20% reduction in what I feel a bit uncomfortable about plugging that too much, but feel free to have a look. Regenerative says that we're starting to become very good about fixing the things. So the energy efficiency, we've got pretty good at making better chemicals and the batteries we get in there. What we've not been very good at is changing the way we behave, the mental side of things. So the regenerative thinking is how do you develop both how we fix the physical side of things, but also how we deal better mentally with all of the aspects that we're dealing with in our environment. And that's quite exciting because you can just see people go, oh, okay, so if I fix that and I behave this way, then I'll start contributing. And that's a very exciting part And the whole intention behind what I've just shown you is that we're starting to move from this, being less bad or efficient to neutral, which is kind of in the middle, the sustaining bit, to the top bit, which is about regenerative, or moving from harmful to neutral to beneficial. Stop being apologetic for being around. The world would be better off without humans and kids sometimes. The world is better off because of us. And there's a few tools that are working towards that, and I have some more stuff in here, but I won't go through some examples of buildings that are positive and some tools out there. But really, I'll stop there. There's a free documentary that I've just had the premiere of on Tuesday morning. You can download it up there, which talks more about this idea of regeneration. There's my book, and feel free to send me comments. Thank you.
Yeah.
Do you have time for questions?
Sure. Does anyone have any questions for Dominique?
I'm interested, you might want to talk about the green roof. It's obvious that the green roof is going to help as far as what goes back into the atmosphere or affecting that. What goes into the house is also going to be dependent on the existing insulation and other factors. So what kind of insulation or lack of did you have in those test buildings?
Okay, so the retrofit buildings we brought into the code, we built the, as required, I think it was 2.25 in the ceiling or 2.5 in the ceiling. My brain's going back to 2010. And in the walls 1.2, I think. So we brought the building up to code. So we tried to bring it up to 5-star at the time. And then the little buildings we built new to 6-star.
Well, that's interesting because the reason I ask is that I really get the impression that you might even be better off without the insulation because of the benefit of what you were doing on the outside.
The problem with that is that in winter, because the R value varies, it will be worse. Yeah.
Do you need to improve the structure before you put a green roof on?
Yes, so it depends on the building you have, and that's where the growing green guides come in. It talks about different structures, but yes, it will reinforce the structure. And depending on the structure that you have existing, you could go for an extensive or a thin roof or an intensive and a thicker roof, and then that will determine what plants you can plant. But yes, I wouldn't go for big on this much soil without checking, because the soil's fine, but once the water fills up the water, very cold.
There's often seemed to be a bit of a conflict between greening a city, as in having vegetation, and having a compact city which has all sorts of environmental benefits as well.
Yeah.
And sort of biourbanism is presented as a kind of way of resolving that conflict. Do you want to say something about that?
So as I said, we get the biophilic benefits from not just nature, but also references to nature. Having said that, we need all, so we will continue to need our green spaces. I had some students look at a site in Footscray where we took two normal housing blocks, 12 metres by 40 metres, back to back. And then they looked at how they could double the density, but double the greenery at the same time. And so it is possible, because particularly if you're designing new, you can design the structure to have the green rooms, and you can design the way that people interact with the site to increase the greenery. So yes, the way that we're currently, in my neighbourhood at least, lots of the single houses are being knocked down and they're putting duplexes or more than that on there, without any thought of how to bring more green amenity to the people. I think that's poor practice. So I think we can do it well, we're just not doing it well at the moment.
Can you have a green roof and collect a reasonable amount of rainwater?
No, that's a great question. So many of you have been researching how much rainwater we get, only 20% of the rainwater. Yeah. So I've worked with people who want rainwater. We've done the green roof segments of greenery. We've used green walls to try and retain, or there's a project in Castlemaine that we're working on. We're using where the park colleges and so forth to collect the rainwater with the solar panels. It's very small site. Greenery wherever we can, put a green facade as opposed to green on the roof because we want to collect that greenery. Yes, it reduces it, which is good from a storm event. Reduces it by 80%.
With the green walls, has there been any experimentation with vines? Because I've got a vine in my back garden over my garage and it produces effectively a wall, which makes a huge difference.
Yeah, so within the green growing green garden, it talks about which types of vines avoid. The research that my student is doing on biologically feasible, how to determine what's biologically feasible, also has a whole list of vines that you can choose from depending on how hardy the vine is. Some of the hardier vines tend to attach themselves to buildings and some people. So he talks around the best choices depending on the wall surface that you have and how you mount it. But yes, vines do provide a benefit because again you've got the green surface absorbing that heat and evapotranspirating and then using the thermal heat and light and transferring that into the energy for the plant. Sorry, what question?
Just maybe not construction question. Have you thought about the average home in suburbia? How you could do
The average home.
the average home in suburbia?
Yeah.
Do a pitched roof, do a green roof, or you have some that's I'm just thinking about the uptake of it.
Yeah. So the more project was your average, middle suburban. We looked at all of the stock and all the different roof types, and we actually gave more of the roof space to solar. Because the aim was trying to be carbon positive, so we gave a lot of the roof surface to water collection and solar, and then we tried to maximise the greenery in the gardens, green walls. So yes. There's a great article by David Pomegranate on permaculture and how to use permaculture across our real suburbs, which is worth looking into.
I live in a block of flats and I'm the chair of the community management side of the cloud. And at the moment I keep my green roof to start with some green walls. But my problem is that the building is at least 2 stories high. And then it's maintenance of whatever would grow up the wall once it was high enough to manage. And the other issue is the recovery and how we keep the vines out of that and it's that high.
Yeah, so it's a careful selection of your plants. So like I said, meaning NH is some of the people, I'm not the right person, I'm not. Even though I did botany as my first degree, it was more on the ecological side than on plant species. I have students working on that. Final question.
How do you deal with the slate roof and heritage requirements?
This is where going down the white roof path is an option. So green roofs just aren't appropriate for probably 60 or 70% of the roofs that we have. You can see the white roof paint is a technology that's kind of like a sunscreen, and it's very crude to explain it like that. But you can get it as a clear film, or you can get it in a grey or a green or a red, depending on your heritage requirements. It's just not as effective as the white because it has some of the reflections outside the colour zone, but it will still have the absorption within the colour zone. So it can reflect the infrared, but not within the colour zone. So your best options are your white plus the nanoparticles that they're using, but you can use other colours. And full report. Dulux has a paint across all the colour range that has these nanoparticles in it.
Okay, so we might wrap it up there. It's all right. Any questions? Thanks a lot, Dominique. It was a really great talk, and there's a lot of ideas.
Yeah, sorry, I went a bit fast at the end.
Okay, so our next speaker is Dr. Rob Salter, who's going to talk about Livewell Clusters. It's a project he's been working on as a member of the Centre for Low Carbon Living, which is based in Perth. He's based at Curtin University, but he actually lives in Richmond Hill, and works out Melbourne due to the London weather. And he's also my mother-in-law's science claim next to me.
There's about 200 of them, so there's plenty if you want to take multiple copies. But if you want to take a large number of multiple copies, maybe just wait to see how many are left at the end, and we'll put them down there, and then we'll see how many over and take that. So these are just flyers which you might want to put. Your own details also share it's about Livewell launch, which is coming up in March. And also, if anyone would like to take a poster to put up in their workplace or organisation, those out as well. There's only about sort of 10 of those, but if you like to use one of those, that would be good. All right. Okay, so yes, the project is called Livewell Clusters, and it's a project which is designed to help people to reduce their carbon emissions. It's starting in Yarra, and in Yarra it's going to be called Livewell Yarra. And if it's successful, the aim is that it can be implemented elsewhere. As Chris was saying, it's part of a CRC, which is the Cooperative Research Centre for Low Carbon Living. Now that's a national consortium of 5 universities plus the CSIRO plus a group of businesses, often quite large businesses, and government bodies such as state government departments, federal government departments, some councils, some utilities and so forth. And together, as this consortium, they managed to get funding from the federal government. The CRC mechanism is a mechanism which funds large projects on particular themes in a whole range of areas. There was a CRC on pork production, a CRC on water sensitive design, and all sorts of things. So this is a mechanism through which the federal government funds research on particular themes. So this one is on low carbon living, and so this CRC has funded, I think, about 40 or 50 projects so far, and this Livewell Clusters project is one of these. And I'm actually employed by Curtin University, which seems a bit strange because I'm here. What happened was that my wife and I went over to Perth for 2.5 years, and I got work at Curtin, and we always had the intention of coming back. And my wife got a job here, and so It's all happening in Yarra from the 5th of March when we've got our launch at Victoria Town Hall in the evening. And we're lucky to have Ross Garner coming on to talk. He's actually a Yarra resident and know him, so it's fortunate that we can get him on to talk at the launch. So it's in 2 weeks from today. And our second speaker who will speak briefly is Fiona Armstrong, who has started up an organisation called the Climate and Health Alliance, which is pointing out the connections between our health and our climate. And really, it's a twofold connection. One is that obviously, if the climate deteriorates, our health will be seriously affected in all sorts of ways. But secondly, if we live a low-carbon life, there are all sorts of health benefits that can be gained from that as well. In terms of living in a more comfortable home, if we're engaged in active transport, walking, cycling, or public transport, which typically involves about a half an hour walk if you're using public transport to commute each day. So there's all sorts of benefits. So Ross and Fiona are coming on to talk at the launch, and then we'll get into some real audience engagement, because it's a project about people who get involved participating in the running of Livewell Clusters. We don't have any big bag of money. I mean, there's some initial money from the research project, but we don't have any other source of money. So it's going to be a real member-run, participant-run organisation, and so we'll be encouraging people right from the start to get involved in it. And everyone is welcome to come. In terms of the features of Livewell Clusters, because there's lots of other environmental organisations and organisations addressing carbon and climate change. So the question is, why are we creating another one? Well, we think that there are some distinctive features that can really help to engage people and help them to make changes in their lives. Probably the central one is the concept of what we're calling deep harm groups, in which people get together in groups of, say, between 6 and 12 people. Might be in the neighbourhood, might be with friends, with people from the same church or workplace, or members of a school parents group, or whatever group might be. And so those people will meet monthly, and at the beginning we'll help them to work out what their carbon footprint is, what they're high in, what they might produce. We'll be providing various sorts of information. We've got a website. We're going to be running various workshops and events. We'll give them advice as necessary on a one-to-one basis. We can refer them to other experts. And we also are looking at starting up some what we call project groups that in some way or other will sort of focus on a particular topic that will make it a particular subject. Make some changes there to make it easy for everyone. For example, one of the things we're thinking of is we're thinking of getting a project group going that will set up a series of cooperative working bees in people's homes, so that they can do simple retrofitting jobs in each other's homes. So you might have this group of people who go around to each person's home in turn, and the person whose home it is identifies a particular job, and those people would help with that job, or they might have a series of small jobs. So might be a bulk buying, working at a project group, a group might organise a walking school bus. So people heard of a walking school bus? some people have. But it's a system of encouraging children to walk to school. You know, when I was young, probably when you were young, everyone either walked to school or caught a bus or something like that. Nowadays, it's much more common for people to drive. That's contributed greatly to like all forms of driving contributes to greenhouse emissions. So it's also not good for people's health. So this is a way of getting kids with parents who are rostered to supervise them, get them walking to school in groups, and drive, picking up kids on the way, and that's what's called walk to school bus. So that's another idea. Might get a food gardening group going. So basically what we've come up with is the central sort of structure is the decarb groups, and around that we're going to try and create all sorts of activities that will support these groups to in turn support the individuals within them to reduce their carbon footprint. And we hope that in the process people have a good time too, because people like to get together, we're social people, you know, we're social animals, we're encouraging people to make sure there's lots of socialising time, a meal or refreshments together, and generally have a good time. So that's the kind of kernel of Livewell Clusters. It's about people getting together and helping one another to reduce their carbon with the support of other organisations, because